Hello everyone, here are your notes for 9.7, Law of Sines. So, when we use the law of sines, we need to make sure that we use it only on non-right triangles. You can use these on regular right triangles, but we have other methods like just using regular sine, regular cosine, and tangent to solve those right triangles. So there's no need to use it, which is why we only use this really for non-right triangles. But it will still work, of course, on any triangle. All right, so here's what the law of sine says. If I have a triangle ABC and across from angle A, so if we go right across, this is side BC. Across from side BC, I'm going to write little a, and little a represents the side length of BC. Across from angle B, I'm going to have little b, and across from angle C, I'm going to have a little c. Let me go ahead and write this down as a reminder. Little a, little b, and little c are side lengths. Okay, and if we have this triangle, this is the law of sines. We take sine of angle A and we divide it by little a. And this is going to be equal to sine of angle B divided by little b. And of course, last but not least, this is equal to sine of angle C divided by little c. So this right here is our law of sines. Not anything too crazy, but the solving, the calculating part is going to be a little bit of a lengthy process. All right, so let's go ahead and let's show you what that process looks like in example 1. Given the measures below, they want us to solve for side C. Now, there are going to be two different cases. The first case, we're going to go ahead and we are going to solve for a side, and that's what little c represents. We're given that angle A is 33 degrees, angle B is 105 degrees, and little b is 37 9/10. Apologies for the degree, you can go ahead and cross it out. Because little b is a side, it is not an angle. So let's go ahead and let's label our triangle as A, B, and C. And then we can go ahead and we can fill in this triangle with the proper measurements. They tell us that angle A is 33 degrees. Let's write that in. Angle B is 105 degrees. And angle C, we don't know. But we do have little a, little b, and little c. And the only length that we are given is little b at 37 9/10. Okay, so after we go ahead and label the triangle and put in the measurements, let's go ahead and let's now rewrite the law of sines. Just to remind ourselves what it is. Sine of angle A divided by little a, sine of angle B divided by little b, and sine of angle C divided by little c. Okay, now once we've done this, so we've went ahead and like I said, we labeled the triangle and we've labeled the parts as well. And after writing the equation down, we can now substitute into the law of sines. That's step 1. So let's go ahead and do exactly that. So substituting in, we have sine of angle A. We know what that is. It is 33 degrees divided by little a. Since I don't know what that is, I'll go ahead and leave that little a there. This is equal to sine of angle B. We do know what that one is. That's 105 degrees divided by little b. And we do know what that length is as well. It is 37 9/10. And this is equal to sine of angle C. We don't know what angle C is. Divided by little c. Don't know what that one is either. Well, that's okay. All right, so that takes care of step 1, which is to substitute into the law of sines. Step 2 tells us to pick two proportions. Now, how do we know which two proportions to pick? Because there are three here. One of those proportions, or fraction, you could call it as well, one proportion is complete with values. Here's what I mean. When we take a look at the entire proportion, the entire fraction for each of these three, what I'm looking for is that both the angle and the side across from that angle have a value, have been substituted in. So if we were to take a look at all three of these, we see that the middle proportion, the proportion that contained angle B and side B, little b, that is complete with values because we knew what the angle was and we knew what the side was. Visually on the triangle here, what that looks like is that you have an angle and a side opposite that angle, and they both are provided, or we have both of these values. Okay? Notice how for angle A, if I were to group up angle A with little a, this is not a complete set because I don't have the missing side, A here. All right, so that's the first proportion. The second proportion must contain the variable we're solving for. Okay. So of course, if we are solving for a particular variable, it must be in one of the proportions that we chose. Now, when I take a look at the problem, it told me that I'm trying to solve for little c. So that right there tells me that the other proportion that I'm going to use needs to include little c. And that's going to be the third or the last proportion. So now we've went ahead and picked our two proportions that we're going to use to solve. Let's go ahead and take a moment to rewrite these in an equation. So we have sine of 105 degrees divided by 37 and 9/10, and this is equal to sine of angle C divided by little c. Now we can kind of start looking at how we're going to solve for little c. But I do run into a small dilemma here. I have two missing variables. I do not know what the angle of c is, and I don't know, or I'm trying to solve for little c as well. If I were to try and solve, I would not be able to finish solving for little c because I don't know what angle c is. But let's go ahead and let's go back to our triangle for a moment here. In our triangle, if I were to look at the triangle, we are given two angles. I'm given angle A and I'm given angle B. What we were missing in that equation is angle C. But here's the thing. We can actually solve for angle C even though it wasn't provided for us. I can go ahead and I can take angle A and add it together with angle B and then add it together with angle C, and that should all equal 180 degrees because this is the triangle sum theorem. This is a theorem that we learned kind of like at the beginning of this chapter, and we don't use it all the time, but we use it when it's convenient for us. It's a tool that we have in our tool belt, and we basically just pull it out when we need it. And now is a time when we need it. So substituting our values in, the measure of angle A is 33 degrees, plus the measure of angle B, which is 105 degrees, plus the measure of angle C, which is what we want, and this is all equal to 180 degrees. All right, finishing this up, we have 138 plus the measure of angle C is equal to 180 degrees. Subtracting 138 on both sides, we get that the measure of angle C is equal to 42 degrees. So now I can go ahead and I can label angle C with 42 degrees. And this is what I'm going to substitute into our equation down below as well. All right, substituting in. Everything else remains the same. The only thing that changed is that angle C, we now know, is 42 degrees. Okay, and then from here, now that we have our proportion set up, we're going to go ahead and we are going to cross multiply to begin solving. So I'm going to cross multiply C to sine of 105, and I'm going to cross multiply 37 and 9/10 to sine of 42 degrees. And here's what we get. We get C times sine of 105 is equal to 37 and 9/10 times sine of 42 degrees. Now, just a piece of advice, a word of advice. Any variables or any values that you are multiplying with sine of something else, write it in the front, write it on the left side. This is to help you keep you from being confused and trying to decide, okay, am I supposed to multiply 42 with 37 and 9/10, right? If you had written this on the right side, you might accidentally multiply these two numbers together. So instead of writing them on the right side or in the back area right here, we will go ahead and write the numbers in the front so that we know that, oh, this is 37 and 9/10, and you multiply that to sine of 42, not just to the number 42. Okay, now, last and final step in solving here, we're going to go ahead and divide both sides by sine of 105. The reason why? This is C times sine of 105. And sine of 105, it's really just a number. Just like if this were to say 3 times C. Right? If it said 3 times C, you would divide on both sides by 3. This is sine of 105 times C. So we divide both sides by sine of 105. All right, so on the left side, things cancel out, and we are left with C is equal to 37 and 9/10 times sine of 42 degrees, all divided by sine of 105. All right. Now, because we need to actually get a number, a value for an answer, we're going to go and we're going to take this and put it right into a calculator. All right, so go ahead and pull up that Desmos calculator. Now we're going to go and type everything in as we see it. Okay, so of course we're going to go ahead and begin with 37 and 9/10. And this is going to get multiplied with sine of 42. I'm going to make sure that I close up that parentheses. Okay, and now one other thing that I'm going to do is I'm going to group 37 and 9/10 and sine of 42. The reason why I'm doing this is because all of this is getting divided by sine of 105. Closing up that last parentheses, hitting equals, we go ahead and get our final answer. It is about 26 and 25 hundredths, but I do want to make sure that I round, right, to the nearest tenths. And so I'm trying to figure out, is this 2 going to go up to a 3? Or is it going to stay a 2? And because the number next to it is a 5, this becomes 26 and 3/10. So our final answer here is that C is approximately 26 and 3/10. All right. So that right there is our example for using the law of sines. Oh, one last quick thing I want to mention. We did use the triangle sum theorem up here to solve for the measure of angle C, but I just actually want to let you know that we don't always need to use a triangle sum theorem. Again, it's just like a tool in your tool belt. We don't always use it. We only use it when we need it. All right, so go ahead and pause the video here and see if you can give this one a try on your own. Alrighty, go ahead and double check over your answers. The measurements given for this U-try was actually the same as example 1. It's just that instead of looking for little c, they're now asking us to look for little a. So we go and substitute the values in and decide, oh, these are the two proportions that we're going to use. And then I went ahead and rewrote that equation and started to solve. Notice how for this problem, I did not need to use the triangle sum theorem. And again, it's because I did not need it. It wasn't a tool that I needed to use this time around. Right, so then finishing the solve, we get that A is approximately 21 4/10. All right, now let's go ahead and take a look at case 2, which is solving for an angle instead of a side now. Now, if you remember from the previous notes in using inverse trig, we use inverse trig when we need to solve for an angle. So because we are solving for an angle here, and because we are technically using sine, at some point during the solving, we're going to have to use the inverse trig ratio. Okay, so I'm going to just write it there as a reminder to myself that, okay, the setup might be the same, some of the steps might be the same, but there is going to be a step where I will need to take the inverse trig on both sides of the equation. So let's go ahead and, of course, label the triangle one more time, triangle ABC. Across from angle A is going to be little a, across from angle B is little b, and across from angle C is little c. Filling in the triangle with our measurements, angle A is 88 degrees, little a is 26, and little c is 21. All right, now, again, very similar steps because we have to use the law of sines here. This is a non-right triangle, and so that means that we do need to use inverse trig. The law of sines. So writing down the law of sines first, we get sine of angle A divided by little a is equal to sine of angle B divided by little b is equal to sine of angle C divided by little c. Let's go ahead and substitute all of the values in. We know what angle A is, so we are taking sine of 88 degrees divided by little a. We know what that one is too. That's 26. This is equal to sine of angle B. We don't know what that is. And we don't know what little b is either. And this is equal to sine of angle C. Whoops, don't know that one either. But we do know what little c is. Little c is 21. All right, so next step, of course, is to figure out and decide which one of these three proportions we're going to use to solve. Well, one of them has to be complete with values in both the numerator and the denominator. So taking a look, sine of A divided by little a has everything that we need. We have the angle measure. We also have the side measure. In the triangle, we can see that the angle and the side opposite that angle have values that were provided to us. All right, and then for the other proportion, it needs to, of course, contain the variable that we're solving for. So if we're solving for angle C, well, then we better use the proportion that contains angle C. All right, let's now go ahead and rewrite these two proportions together in an equation. So we have sine of 88 degrees divided by 26, and this is equal to sine of angle C divided by 21. Now, there's actually two different ways to solve this, and I'll go ahead and I'll show you one way, and then quickly talk about the other way. So what we are trying to solve for, keep in mind, is angle C. So if the variable is on the right side of the equation, then I want to get rid of everything that's on the right side of the equation. So I want to get rid of this 21, and I also want to get rid of this sine. In order to do that, I need to do the opposite operations for both of these. Now, keep in mind, I know some of you like to read this as sine of angle C over 21. But if you've noticed, I've been reading this as sine of angle C divided by 21. So if I'm dividing by 21 to cancel it out, to get rid of it, I need to do the opposite, which is to multiply by 21 on both sides of the equation. So we're going to do exactly that right now. I'm going to multiply 21 on both sides. Here's what we get. My 21s on the right side cancel out. And I'm left with 21 times sine of 88 in the numerator. Again, because this is technically 21 divided by 1. And when we multiply fractions, we multiply straight across. Numerators multiply and denominators multiply. So 21 times sine of 88 divided by 26 is equal to sine of angle C. Now we're almost done. In order to get rid of this operation sine that is working on angle C, or is being attached to angle C, we now need to take sine inverse. So this was what I mentioned earlier. When we solve for an angle, you need to take the inverse trig ratio at some point when we solve. And now is the time when we go ahead and do exactly that. So we take sine inverse of 21 times sine of 88 degrees divided by 26. And this is, of course, equal to sine inverse of sine of angle C. And because these are opposite operations, sine inverse and sine cancel each other out. Another word of advice and another word of warning, really. This sine inverse, we are taking, it is operating on the whole left side. It is not just operating on the sine on the inside here. We are only allowed to cancel if the only thing that we're taking sine inverse of is the regular sine. And there's nothing else attached. There's a 21 here. There's also a 26 down on the bottom. So this means that I cannot cancel out my sine inverse and sine. We leave it as it is. So finally, at the end of the day, what we get is that angle C is equal to sine inverse of 21 times sine of 88, all divided by 26. And of course, this is where we want to use the calculator. All right, so in the Desmos calculator, here's what we're going to type in. That outside operation is sine inverse. So that's what we're going to type in first. Go to the function tab, type in sine inverse. And then we're going to go ahead and now type in 21 times sine of 88 degrees. We're going to close up that parentheses after 88. And here's the other thing I'm going to do. I'm going to go ahead and group together 21 times sine of 88 because all of that will get divided by 26. And then last but not least, we're going to close up that final parentheses, hit the equal sign, and there is our final answer. It says 53 and 82 hundredths. If I want to see if I need to round up to 53 and 9/10, or do I leave it as 53 and 8/10, I look at the 2 next to the 8. And because it's a 2, we're going to leave our answer as 53 and 8/10. So, angle C is approximately 53 and 8/10 of a degree. All right. So let me go ahead and quickly show you the other way that we could have solved this. So we had sine of 88 degrees divided by, I believe it was 26, is equal to sine of angle C divided by 21. So if we wanted to, what we could do is we could still cross multiply, just like we did before. When we cross multiply, we get 21 times sine of 88 degrees, and this is equal to 26 times sine of angle C. Now, if you had went ahead and cross multiplied, a good question you might have here is, how do I know if I'm going to divide on both sides by sine, or if I'm going to take sine inverse on both sides? Here's what I'm going to ask you to do. Take a look at the value or the number or the variable that comes after the sign. Okay, and we're going to break it up like so. When you look at whatever is after a sign, if it is a number, then we know that we're going to need to divide on both sides by sine of whatever that number is. But if we are looking at a variable, which is the case that we have here, angle C is a variable, we don't know what it is, we're trying to solve for it. This is how we know to use sine inverse or inverse sine on both sides. Okay. So, like I said, for this particular problem, we're looking at a variable after sine. So what that means is we are going to use sine inverse, but we first have to make sure that we get rid of everything on that side. It needs to just say sine of angle C. So in order to make sure that it does that, we're going to divide by 26 on both sides. My 26's cancel out. I'm left with 21 times sine of 88 degrees divided by 26. And this is equal to sine of angle C. Finishing this up, like I said, in order to finish solving, we need to take the sine inverse of both sides of the equation. And so we're taking sine inverse of 21 times sine of 88, all divided by 26. And this is, of course, equal to sine inverse of sine of angle C. My sine inverse and sines cancel out, and I actually end up with the exact same answer as we had earlier, which is sine inverse of 21 times sine of 88, all divided by 26. And this is equal to angle C. And this, again, was where we needed to put in the calculator to get our final answer. All right, so final you try for the day. Go ahead and pause the video here and see if you can give this one a try on your own. All right, so go ahead and double check over your answers. Now, in this particular problem, again, they want us to solve for an angle. Because I knew that we were solving for an angle, I made a mental note to myself that I need to use the inverse trig. So, again, everything else is the same though. I'm going to go ahead and write down law of sines, and I'm going to substitute the values in, and then I'm going to decide which two ratios are we going to use. And because I'm solving for angle P, I know that I'm going to be using this first proportion for sure. And the other proportion that is complete with values was the one that used angle Q and little q. All right, and then I went ahead and rewrote everything. Again, I took a very similar approach to the last problem, which is to multiply on both sides by 19 because we are dividing by 19. And then we go ahead and take sine inverse on both sides to cancel out that sine. And now I'm finally left with angle P Put all of this into a calculator, and we get that angle P is about 59 degrees. All right, so that is it for your notes for 9.7, Law of Sines. Thank you very much for watching, and I'll see you in the next one.